All right, let's dive right into this explainer and absolutely demystify how you can completely modernize your packet radio setup. Look, if you've been relying on aging hardware or, just feeling restricted by the complexities of traditional packet radio, you are in the exact right place. Today, we're breaking down the Direwolf software modem. This is a tool that is fundamentally reshaping how we interact with APRS, the automatic packet reporting system, and it's literally revolutionizing the traditional TNC, or terminal node controller. We're going to unpack the official user guide and get you up and running efficiently.
So here's our game plan for today. First, the software TNC revolution. Then, connecting your radio setup. Third, crucial settings for success. Fourth, installing Direwolf. And finally, integrating client applications. Let's get to it.
Section 1. The software TNC revolution. So the days of relying on specialized, super expensive hardware terminal node controllers, yeah, those are completely gone. Back in the early days, you had to have this dedicated physical box sitting between your radio and your computer. But today, a software modem fundamentally changes the whole game. Basically, by just routing audio into your computer's Soundcard and letting Direwolf's advanced algorithms do all the heavy lifting, you get vastly better results at a fraction of the cost. To put that into perspective, on standard benchmarks like the WA8 LMF TNC test CD, this software approach actually decodes over 1,000 error-free frames. It completely outperforms a lot of legacy hardware units. And Direwolf's versatility goes way beyond standard setups. I mean, it's not just some basic 1200 baud modem. It dynamically decodes 300, 1200, and 9600 bits per second data rates. Even better, it is fully compatible with modern software-defined radios like GQRX and SDR Sharp. So whether you're running Windows, a Mac, or even a tiny little Raspberry Pi on Linux, Direwolf transforms that hardware into an absolute powerhouse capable of running an internet gateway, a Digipeater, or an APRS gateway.
Moving on to Section 2, connecting your radio setup. All right, grounding ourselves in the physical world for a second, getting your radio to actually talk to the computer is incredibly straightforward. It is literally just routing basic audio cables. For receiving, you just take your radio's speaker output and plug it into the line in or microphone jack on your computer, and if you want to transmit, just route the computer's audio output straight into your transceiver's microphone input. It's standard audio routing, nothing proprietary or crazy here. Of course, receiving is really only half the battle, right? To transmit, your computer needs to tell the radio to key up. That is usually done via a push-to-talk or PTT signal. Traditionally, this was triggered using specific pins on a serial port. But if you're looking at the back of your modern PC right now, you might be a little intimidated if you don't see a standard RS-232 serial port anywhere in sight.
Well, checking your Windows Device Manager often reveals a pretty wonderful secret. That communications port is frequently completely active, just hiding right there internally on your motherboard. You usually just need a really cheap adapter cable to bring that connector out to the rear panel, and boom, you've got instant, reliable PTT control without messing around with any complex USB adapters. Okay, Section 3, Crucial Settings for Success. Before we even touch the software, we've got a quick-fire cheat sheet straight from the source material to optimize your radio. For receiving, you absolutely must leave that squelch completely open. If it's closed, the squelch delay actually cuts off the very beginning of the data packets, and you just won't hear the weak ones at all. Also, turn off your battery saver. It rapidly cycles the receiver power, and you will definitely miss incoming frames. On the transmit side, setting the proper audio level is vital. Too high causes distortion. But listen up, here is the most critical warning. Absolutely disable your radio's built-in Vox. Vox is designed for human voice, which means it keeps the transmitter on for about a half second after the sound stops. In packet radio, a half second is an absolute eternity. It hangs the transmitter for way too long, causing massive collisions with other stations. Just use a wired PTT or a dedicated hardware timer. All right, Section 4, Installing Direwolf. The Windows installation proves just how incredibly lightweight and efficient this tool is. There's no bloated, complicated installer that's going to bury a bunch of files deep in your registry. Nope. You just download the zip file from the releases page, extract it all into a convenient user folder, and you're basically done. Once it's extracted, you simply right-click the direwolf.exe file, select Send To, and hit Desktop, Create Shortcut. That drops a distinct little wolf icon right on your desktop, and that is exactly what you'll use to launch your new software TNC. It really is just elegantly simple. Actually, wait, I do want to preempt a major gotcha for Windows users that the user guide explicitly highlights. It has to do with the default command prompt window that Direwolf runs inside.
So Windows defaults the command prompt to something called raster fonts. Well, raster fonts have an extremely limited character set. Since direwolf supports UTF-8 characters for global compatibility, if you leave that default font on, you are going to get rendering errors or totally unreadable text on your screen. You have to right-click the title bar, go to Properties, and select a modern font, like Consola's or Lucida Console, to make sure everything displays flawlessly. Don't skip that step.
Now, for our Linux tinkerers, whether you're on a desktop or a Raspberry Pi, the setup involves a quick compile from source using a Git clone. But my absolute pro tip here from the documentation is step 2. You literally must run sudo apt-get install libasound2 dev before you attempt to build. If you skip this, the compiler is going to throw a fatal ALS a directory error and stop dead in its tracks. Install that library first, save yourself an hour of forum hunting, and your build process will be perfectly smooth.
Finally, Section 5, Integrating Client Applications.
Direwolf is incredibly powerful on its own just for observing traffic, but its true power really shines when it acts as the engine for your favorite packet radio apps. It actually hosts an internal server using the AGW network protocol, which allows up to 3 different client applications to connect simultaneously. You can easily bridge Direwolf to mapping and messaging apps by creating a new AGW-type port in your client software, simply pointing it to your computer's own IP address, localhost, and setting it to port 8000. But here is another massive, empathetic warning for users of the highly popular APRS CTE/32 client. Pay close attention to the Messages checkbox in your AGW port configuration. By default, it is turned off. If you don't explicitly check this box when setting up your port, any attempt you make to send an APRS message will just silently fail without giving you any warning or error whatsoever. It's a tiny detail, but knowing it will save you hours of frustrating troubleshooting. For UIView 32 users, the setup is just as uniform and easy, which really proves how tightly integrated this ecosystem is across different software. You just jump into the comms setup, select AGWP as the host mode, type in localhost with port 8000, and you're good. In a matter of seconds, UIView 32 is sending and receiving flawless packet data right through your Direwolf software modem. So the transition from expensive, specialized, and aging hardware to a totally flexible, incredibly powerful software modem is officially complete. You've got the settings, the connections, and the integration pathways. So as you look at your newly modernized digital station, I want to leave you with this. What advanced APRS networks and packet configurations are you going to build now that those old hardware limitations are completely gone?